Day 3 is all about using triangle similarity to find missing lengths. Now, the interesting thing is, you're not always going to have triangles set up in the exact same position. So you have to be able to see the corresponding sides because the concept doesn't change. You put corresponding sides together to get the ratios. So let's look at what we have. Given two similar triangles, we can set up a proportion to find a missing side length. All right, so if you look, this is the short leg of that triangle. So is this. Okay. So now we're going to go, let's take a look at the long legs. Here's the hypotenuse of that right triangle, and here's the hypotenuse of the short right triangle. So the ratio we have set up here, look at what we have. We have the large triangle, short leg, and the short leg, don't we? Oops, short leg and hypotenuse, my bad. We have the short leg and the hypotenuse of the same triangle. That's in the numerator. So we're going to put corresponding parts together. So the short leg on the other triangle is 2. The hypotenuse on the other triangle is 3.5. Okay? A ratio of corresponding sides. So let's do the math. Different color. You end up with 3.5x equals 14, divide 3 by 3.5, and x equals 4. Now, sometimes it gets hard to see, so what you can do is you can redraw. Okay, we know the small triangle is a right triangle, which you better draw better than I do. Oops, okay. So we're going to redraw this. There's my little right triangle. And the hypotenuse is 3.5. And the short leg is 2. And we don't have a measure for the long leg. But now the triangles look the same. They're facing the same way. So sometimes redrawing the picture can help you understand what's going on. It's not a requirement. It just helps sometime. All right. So let's try another one, changing the color. I'm going to determine the value of x. So there's x, and corresponding sides, it corresponds to 2. And let's do the hypotenuse, because the hypotenuse is really obvious. We can always tell which one is the hypotenuse. Okay? So that would be 5 and 4. Am I right? Yes, I am. So now, cross multiply. Okay. So we have 4x equals 10. Divide both sides by 4. X equals 2.5. Well, what if you set it up differently? Let's try it. Let's set it up a different way. All right? Again, corresponding sides are what we really have to focus on. So let's look at setting the short side and the hypotenuse of one triangle, x over 5, equals the short side and the hypotenuse of the other triangle. All right, so let's do the math on this one. Again, cross multiply, and we have 10 equals 4x, divide by 4. 2.5 equals x. See how we have the same answers on both equations? It's because we set them up corresponding. When you set up the corresponding sides and proportions, whether you have corresponding sides in the numerator or whether you have them in one ratio, you are good to go. So that isn't really that bad. All right, let's do another page of math. Again, math, math, math. So now we're going to call this indirect measurement because we don't have all the measurements, but we are going to use math and what we know of ratios to figure out measurements. You've got a pole 3.4 meters tall, casts a shadow that is 1.75 meters long. My idea, my suggestion for you is draw. Okay, I'm going to draw a pole and my shadow. It's a right triangle, we know this. Pole is 3.4 meters tall, shadow is 1.75 meters long. At the same time, you've got a nearby tower, which is really big. Okay? There we go. Nearby tower has a shadow 48.25 meters long, and we don't know how tall the side is. So now that we have some pictures, some drawings that may help us. Okay, let's look at our ratios. 3.4 to 1.75 is the same as x over 48.25. Object over shadow equals object over shadow. Cross multiply. 1.75x equals 164.05. Divide by 1.75. And x equals 93.7. Now, pay attention. Round your answer to the nearest meter. If you get it wrong, it's because you did not follow the directions. Final answer would be 94. Okay, pay attention. So let's talk about this one. You've got a tree 10 feet long. Cast a shadow. So let's do one tree. Well, I'm going to draw a tree. Tree. Mrs. Gates is really bored. Tree. Okay, this tree is 10 feet tall. And it casts a shadow 12.5 feet long. Then you've got another tree, which is much bigger. This tree, we don't know how tall that is. I'm going to go X. It casts a shadow that is 27 feet long. So let's set up our proportions. 10 over 12.5 equals something over 27. 12.5x equals 270. Divide both sides by 12.5. X equals 21.6. And let's just go 22 to the nearest, to the height of the tree. We usually have in the instructions round to the nearest tenth or round to the nearest meter or foot. So pay attention to that. All right? Not that bad. You are using what you know of ratios to solve indirect proportions. Indirect measurements, rather. Draw the pictures. It helps. All right, triangles and parallel lines. This gets fun. And this is where you're going to get a lot of algebra, and you have to pay really close attention. All right. We know that GH is 12 because it says so. We know that EF is 36. HI is 16. You need to find GE. So we did the first thing. We labeled them. It's a habit. I do it immediately. So you've got HI corresponding to EF. See, that's the base of the triangle. And GH corresponds to GE. Set up a proportion and solve. Well, we don't know the length of GE, do we? We don't know the length of HE. This is what we have to do. You need to put X for the length of HE. We do not know it. And now you're going to go back to segment addition. And you need to remember that HE plus HG equals GE. Okay? Well, HE is X, HG is 12, GE is X plus 12. GE is an equation. Now, let's set up our proportions. Excuse me. So you've got, let's do GH to HI equals GE to EF. Now you're going to substitute your numbers. GH is 12, HI is 16, GE is X plus 12, EF is 36. Now we do our math. Sixteen times X plus 12 equals 432. So 16x plus, getting my handy dandy calculator out, times 16 equals 192. Okay, sorry guys. There we go. 192 equals 432. Subtract 192 from each side. I get 16x equals 240 divided by 16 is 15. Divide both sides by 16. X equals 15, but X is not GE. X is HE. GE equals X plus 12, so GE equals 15 plus 12, GE equals 27. Okay? Now there is a slightly different way you can do this if you want to redraw the triangles. The math still works out. Let me show you that slightly different way. Okay? So this is an option. You can draw G, H, I, and you can draw G, E, F. And then you can label 36, that's X because we don't know GE, HI, make it neater, 16, 12. You can set up your two triangles this way if you wish, and you can go X over 12 equals 36 over 16. You can do it that way if you wish. You're still going to get to the same way because you end up with 16x equals, I'm using my calculator, equals 432. Divide both sides by 16. And x equals 27. So you can do it that way. If you think the algebra may be a little overwhelming, draw two triangles. I've always done it using the equation, but this is a completely valid way. It is your choice. All right, we're going to do one more. All righty, so label what we know. VT is 16. I'm going to do this so we know it's the whole thing is 16. VW is 6. VU is 40. Find VX. That's my X. All right. Again, you can do small triangles. Let's do VW over VX equals VT over VU. Replace the numbers. That's a very messy W. 6 over X equals 16 over 40. 240 equals 16x, and 240 divided by 16 is 15. 15 equals x. That's just one of the many proportions you can set up. There's so many you can set up. You could do it if you wanted to. You could do Vx over Vw. You could do Vx over Vu. Heck, let's do a different one just to show you. Yellow. Let's do Vx over Vu. Vx over Vu equals Vw over Vt. X over 40 equals 6 over 16 to 40 equals 16x, and we know where that's going. The key thing is being consistent. If you do the small one first, you do the small one first and the other one. You must remain consistent. All right, last part of Unit 5, triangles and angle bisectors. All right, so let's do some things. We know two angles in this triangle have marks, and I'm going to highlight them here and here. Remember, those marks mean those two angles are congruent. All right, so what we can say is we can put things in proportion. Y is one side of the triangle, of the smaller triangle, so y is 2, 9, as 4 is 2, 6, okay? Because y and 9 correspond, and 4 and 6. Cross multiply, 36 equals 6y. Divide by 6, 6 equals y. All right, so now this one. Going to do a very quick review on distribution, which we sort of did without reviewing. 5 times x minus 4 is 5x minus 20. 3 times 2 minus x is 6 minus 3x. Do not forget to multiply each piece in the parentheses by what's outside. All right, so now, we're using the same thing. We can use the same concepts, but we're going to have to use some distribution on this one. Different color. All right. 8 and 4 are on the bottom. 8 and 4 are each side of the angles. So the side of the triangle that corresponds to 8 is x. Now the side of the triangle that corresponds to 4 is this piece, but this piece doesn't have a variable, does it? So it is 6 minus x because it's the big piece minus the small piece. Remember, segment addition, it also works backwards. So now we do our cross multiplying. 4x equals 8 times 6 minus x. 4x equals 48 minus 8x. Move your 8x. You want variables on one side. 12x equals 48. Divide by 12. X equals 4. Don't look for patterns in the numbers. Don't look for doubles. Just don't even do that. Okay? The algebra itself is not hard. It's just making sure you get these things set up. So study the triangles. See how in the first triangle, the y and the 4 are together. So the corresponding side to y is going to be 9. The corresponding part to 4 is going to be 6. We put 8 and 4 in the denominator here. The corresponding part to 8, same part of the triangle, is x. Corresponding part of 4 is the whole thing minus that piece, 6 minus x. Okay, don't let this trip you up. When you get practice in Alex, you'll be fine.